guys, welcome back to a LeetCode video, and today we're going to do 24 game. Today's the daily problem. So it's a hard problem, but it's actually not that hard when we just break down into just it's a backtracking problem where you try out different combinations and operators between the numbers. So let's just start off with the example here, and 4187, and you want to try get 24. So basically all it boils down to is just trying out different combinations, which then goes back to a backtracking problem. So for example, let's just start with the solution first. So we try 8 minus 4. So these two numbers, 8 and 4, will minus, and then that gives us 4. So let's just do that first. Get 1, 7, and then you're left with 4. Okay, then afterwards, between any two numbers, in this case we take 1 and 7. In this case 7 minus 1. This gives us 6, so 4 append 6. And then afterwards, these two numbers multiply, and you get 24. So again, 8 minus 4, 7 minus 1, and 6 times 4. Okay, so essentially, that's the solution. But essentially, it's just going to be trying out between any two numbers. You're going to have these 4 different operations that you can try between any two numbers. So for example, if your possible wrong one is that 4 adds into 1, which gives us 5. So that gives us 8, 7, append 5. Okay, so get rid of 4 and 1s. So 4 plus 1. And then afterwards, you can try out between any two numbers again, 8 and 5, maybe 8 minus 5. So you get 7 and then 3. And then we try out something wrong, like example multiply 7 times 3 and you get 21. 21 is not 24, and hence you return false here. Or another one that you can try is let's say 1 plus 8, which gives us 4, 7, and 9. I'm just appending the result at the end. There's always going to be the end, just for standardization. Then another one could be like 4 times 9, and that gives us 7 and 36. Okay. Then the last one could be like minus, which is just straight up wrong, and then it doesn't give us the result. So as you can see, it's just going to be keep on trying between any two numbers. Let's just take another example. 1, 2, 1, 2, and you won't be able to get the result here if we try out between any two numbers. So let's say 1 adds into 2, you get 3. 1, 2, append the 3, then 2 into that 3 gives us 5, and so on, and you won't get the result no matter what operands you try. Another caveat is, let's go back to the operation. So you got plus, minus, exclamation, and divide. Okay. For plus, it doesn't matter what the permutation is, right? For plus, it's going to be 1 plus 3, 3 plus 1. It's commutative. Okay. Then for another one is minus. Minus, it matters because 1 plus 3, 3 plus 1. Sorry, not plus. 1 minus 3 and 3 minus 1 gives us two different results. This gives us minus 2, and this gives us 2. For product, so again, doesn't matter again. 1 times 3, 3 times 1, same negative numbers, and so on. And again, for divide, it matters because obviously 1 divided by 3 and 3 divided by 1 is very different. This gives us 0.3333, and this gives us 3. So minus and divide, we have to actually care about the permutation, and plus and multiplication, we don't have to. Just a small caveat that we have to care about in the code. Okay, so let's get started with the code itself. So again, just try between any two numbers, try the different operands, and then get until your array becomes like a single digit, which should give us 24. Okay, so let's try and start with the code. So first of all, we're going to do a backtracking solution. We're going to recursively try out all the different combinations of the two numbers and see whether or not that works. Okay, so let's just start with subtract, and then we're going to pass in an array of cards. Okay, so our return condition, our terminating condition, is going to be when your cards array is just going to be one single result. So it just contains one element. So blank cards is 1, return true if cards 0 equals to 24, else false. Okay, and then afterwards you're actually going to go try out the different combinations. So for I in range blank cards, for j in range of I plus 1 blank cards. You don't have to strictly do I plus 1, you can do I, or you can traverse the entire array, but this helps me to simplify the fact that this will never give me the same element. We won't compare the same element. Sorry about that. Yeah, so in this case we're just making I plus 1, so that I don't have to worry about the cards, so I don't have to worry about the inner loop and outer loop being the same element. And yeah, so, and now we're going to try the different conditions. So let's just start off with a simple one of add. So for add, we could have a new element that we're going to add of cards I plus cards j. For in this case, suppose that we have the array 4, 1, 8, 7. If we turn out that we're going to be trying 1 and 7, and we're going to add into this, it's going to result in 8. And we're going to take this new number and then add it to our results array. But we want to ensure that once we add, we don't want 1 and 7 to remain there. So it's going to be 4, 8, and your result. Simple as that. So in this case, result will be 8, which then it's just basically going to be a 4, 8, and 8. Yeah. Then we're going to form a new array, which is going to be comprised of everything but the I and j. As you remember, I and j is this is your I plus j, elements I plus j, not the literal index, and everything but I, j plus your result. So yeah, so that's going to be everything but the I and j plus the result. So let's cards I plus 1 up to j. Remember, j is strictly greater than I here, so we don't have to worry about any problems here. So that's the reason why I put I plus 1. I always know that j is going to be bigger than I, so it's easier to form the array as well. But it's really up to you if you're familiar. So cards j plus 1. Sorry. And finally, your actual element that you want to add, new. So all this does is gets all the way up to I, not including the I element, from I plus 1 onwards, up to j, not including j, everything from j, the next index onwards. So if you're not too familiar with indexing here, let's suppose your I and j is, let's pick a longer array, 4, 8, 7, 5. Let's say I and j is this. This, all it does, it takes 4, skips I, which is 1, indexes up to 8, skips 7, and adds 5, and then your result. Let's say 1 plus 7, then it's going to be like this, which then gives us 4, 8, 5, 8. Yep, simple as that. And since add, we don't have to worry about permutation, it's just going to be one single case. I plus j, cards I plus cards j is the same as cards j plus cards I, right? Okay, so for now we're going to do subtract. Just going to copy that. It's going to be pretty much the same logic, but we're going to call it sub 1 because we have different permutations. So cards I minus card j, so that's your first permutation, and second permutation of okay, so all this does is it takes I minus j, the elements I minus j, and this here is going to be j minus I. Remember, if it's like 1 minus 7 versus 7 minus 1, they're going to be different results. So we're going to write our cases, then we're going to call a recursive function, which I'll show later on. Yeah, so let's move on to the next operand, which is going to be our product. Okay, and last one is going to be our divide. Divide 1 because it's going to affect that. way we divide the numbers will matter. Okay, and now we actually want to call a recursive function. And how we're going to do this, we want to actually do this in an efficient way. So once I add these two numbers and I form the new array, I'm going to call a recursive function on that, and then check whether or not I actually get a true, and then terminate and so on. So I don't have to go ahead. If somehow if all the adds add up to 24, then great. I just want to know if that can happen, and I can just terminate. So we're just going to call if new array, then we're just going to return true. So that simple way we can actually have a pruning. We don't have to try out every single thing. So if this branch if it finds out it's 24, then great. Then we're gonna do this here as well. Pretty much gonna do it for everything else. Yep. Okay, so like I said, we're just gonna check again. So just to review, we're gonna try out between every two numbers in the cards array. First one is gonna be add. Second one is going to be subtract, but subtract, remember the order matters, so it could be card I minus card j versus card j minus card I, and add it to the array as well. Let's go into array, and product, it's going to be card I times card j, doesn't matter of the order, and for divide, but the order matters. And then just going to call the recursive function on each of this new array right after we create it. We could technically do it at the end and create basically change the variables to unique variables for each case. But I want to just basically check right away, and this is technically faster. All right. Yeah. So let's go ahead and actually try and run and see whether or not we pass the initial cases. Oh yeah, sorry. Division by 0. So yeah, let's just go ahead and check. Make sure that's not 0. Because some of the subtraction could result in a 0. Similarly here. Oh, sorry, yeah. After, make sure you actually have a final fallback of return false as well. Okay, so we passed the initial two cases, but something that you have to note is when we get a final one, the problem with this, I'll just show you when you print cards, is technically your solution isn't wrong, but because of the rounding, you're gonna get like 23.99999. So what we're gonna do is gonna enhance this with the simple. It's basically gonna use a very tiny threshold. It's gonna call it 24. Yeah. So we're just gonna check if a number falls within this very tiny range, and then just gonna round it off. So and check out whether that works now. Yeah, great. So and that should pass all the test cases. Yep, so that's pretty much the solution. So all it boils down to is just trying out the various combinations between any two numbers, get the new result based on the 4 different operands, add it back to the array, and just keep trying until you get a final element. If it's 24, then that's great. And yeah, we can terminate the backtracking and return true. Yep, so thanks for watching, and I hope to see you for the next daily question.